Good morning, my dear students. Today we will start with the next lesson, dimensional analysis. So, we are going to talk about the dimensions of physical quantities. What do you understand by the term dimensions? So, let us talk about the physical quantity, any physical quantity. Let us take velocity. Now, velocity has got unit. Now, units can be different, like it can have meter per second, kilometer per hour, centimeter per second. So all these units are expressed in different system in different way, like meter per second, centimeter per second, kilometer per hour. But we have the formula for the velocity. Velocity is equal to distance upon time. So if we divide the length upon time, we get unit of length raised to power 1 into time, unit of time raised to power minus 1. So in order to get the unit of velocity, we raise the unit of length to the power 1 and the unit of time to the power minus 1. These powers are known as dimensions. Okay? These powers are known as dimension. The dimension of a physical quantity, the dimension of the physical quantity are the powers to which the fundamental units are raised. The dimensions of the physical quantity are the power to which the fundamental units are raised in order to obtain the derived unit of that quantity. Okay. I'll show you on the board. We have velocity. Velocity is equal to distance upon displacement upon time. This is equal to unit of length raised to power minus raised to power 1 into unit of time raised to power minus 1. This is the dimension. So this is the dimensions are unit of length raised to power 1 and unit of time raised to power minus 1. So these powers are known as the dimensions of velocity. Now we have fundamental quantities. We have fundamental quantities that are length, mass and time. So length dimension, length is expressed as L, mass M, time T. So we write here L raised to power 1, T raised to power minus 1. So this is the dimension of velocity. Or we need not write 1, we will write LT minus 1. Okay. So LT minus 1. Normally when we are expressing any physical quantities in its dimension, then we use only three terms: length, mass and time. So L, length represents by L, mass M, time T. Okay. If the dimension of physical quantities are in length, are A in length, B in mass and C in time, then the dimension of that physical quantity can be written as L raised to power A, M raised to power B and T raised to power C. So that becomes the formula. So any quantity that has got dimensions in A, L A, M B, T raised to power C, then this is the dimensional formula of that quantity. Okay. Now we will write the dimensional formula of certain physical quantities. So we start with area. Now area formula is L square, length into breadth. Now dimensional formula, length is L and breadth is also L. That is L measured in meter, SI unit can be meter square. We can also write in this term m raised to power 0, L raised to power 0, L raised to power 2 and T raised to power 0. But it's not necessary that you should always mention m and T. Okay, if they are raised to power 0, we can simply write L square also. Similarly, volume का formula L cube. So dimensional formula L raised to power 3. Okay. Then we have talked about velocity. The next one is acceleration. Acceleration is velocity upon time. Now velocity का formula क्या निकाला था हमने पीछे LT minus 1 upon time. So this becomes LT raised to power minus 2. From this we can get the unit also. Length की unit meter, time की unit per second square. So meter per second square. Then we have power. Power is equal to force. We have force. Force is equal to mass into acceleration. So this is the formula, mass into acceleration. Mass measured in m, acceleration here LT minus 2. So dimensional formula for force is mLT minus 2. The next one is work. So formula for the work is force into displacement. Now we had found out the dimension for force. Dimension for force was mLT minus 2 and displacement L. So the displacement of work will be mL square T minus 2. Then we have for power. Power is work upon time. So we have got the formula for power. Work is mL square T minus 2 upon T. So this is equal to mL square T raised to power minus 3. So the dimension of power is mL square T raised to power minus 3. Similarly, we have other physical quantities such as momentum. Momentum P is equal to mv. So mass m v LT minus 1. Now there are many more formulas that are given in the table. You have got in the book, there are large number of 41 odd formulas that are given. Some you have read, some you have not read. Some will come in the course of study. As you will study in different chapters, you get different formulas that will come, and each quantity, physical quantity, will be having a different formula, so different dimensions. So in the coming chapters, as and when they are coming, you will also write the dimension for any physical quantity such as surface tension, surface energy, coefficient of viscosity, gravitational constant, angular momentum, torque, latent heat, Planck's constant. All these formulas you have not studied till now. When they will come in different topics, then you will get the formula, and if you know the formula, you can write their basic unit, that is SI unit, changes to MKS system, mass kilogram, mass in kilogram, length in time, length in meter, and time in second. So MKS system, and then you can easily write the dimension for any physical quantity. Okay. One thing is to be kept in mind, that pure ratios and pure numbers do not have any dimensions. Like for example, you have studied about work. वर्क का कंप्लीट फॉर्मूला क्या था? फोर्स इनटू डिस्प्लेसमेंट इनटू cos थीटा. नाउ cos थीटा वर्क क्या था? Fs cos थीटा. So cos थीटा is a ratio of two heights. So there is no dimension for that. That's why I have not written cos theta here. Now if we know the dimensional formula for any physical quantity, we can write its unit also. Suppose for the gravitational constant, the dimension is m raised to power minus 1 L cube T minus 2. Now m is measured in kilogram. So kilogram raised to power minus 1 meter cube per second square. So that is the unit for gravitational constant. The next topic is classification of quantities. On the basis of dimensional analysis, quantities can be classified into four groups. Dimensional variables. These quantities possess dimensions and are liable to variation. Example: force, velocity, work, momentum, heat. They all have dimensions. Then second one is non-dimensional variables. They do not have any dimensions. Example: strain, angle, Poisson's ratio, relative density. Okay. So all these are pure ratios. So they do not have any units. They do not have any dimensions. Then dimensional constant. There are quantities possess dimensions but are not liable to variation. These are constant, like Planck's constant, Boltzmann constant, gravitational constant. So these are dimensional constant. Then non-dimensional constant. These quantities do not possess any dimensions and do not change. Okay, like Joule's constant 4.18 or pure numbers, they are non-dimensional constant. Okay. The next topic is principle of homogeneity. Principle of homogeneity. It states that every equation relating physical quantity must be dimensionally homogeneous. Every equation relating physical quantity must be dimensionally homogeneous. So, from the statement you will not understand anything. I will show you with an example. We have an example: Q equal to W plus X. Q equal to W plus X. Okay. Now, in this equation, whatever is the dimension of Q, the dimension of W should be same as the dimension of Q, and dimension of X should also be same as the dimension of Q. Okay. So, principle of homogeneity means that the dimensions on the left hand side and dimension on the right hand side, and if there are number of physical quantities along with plus or minus sign, then each independent physical quantity should be equal to the dimension on the left hand side. Does this mean? This is Q. Q is heat energy. Q is heat energy. W is work done. Okay. Q is heat energy. W is work done. And X is some unknown quantity. Then dimension of X must be same as that of Q and W. Okay. So dimension of Q भी वही होगी जो W की है, W की क्या होगी जो Q की है, और X की भी क्या होगी जो Q की है. So dimensions of Q and W, work done की क्या है, ml square t minus 2. W की dimension क्या है, ml square t minus 2, ml square t minus 2, and Q is energy. Q भी क्या है, ml square t minus 2. तो X की भी क्या डायमेंशन होगी, ml square t minus 2. Yeah? That is the dimension. This is the meaning of principle of homogeneity. I will give you one more example. Okay, from the equation of motion. We have the equation of motion V equal to U plus AT. You all know what is V. V is final velocity, U is initial velocity, and A is acceleration and T is time. From the principle of homogeneity, whatever is the dimension of V should be the dimension of U and should be the dimension of AT. Okay, independently, the dimension of U should be equal to dimension of V, and dimension of AT should be also equal to dimension of V. Then it is following the principle of homogeneity. Let us V की डायमेंशन क्या है? V की डायमेंशन क्या होती है? LT-1. It is meter per second, displacement of time, so dimension of V is LT-1. And U is also velocity only, so U की भी dimension क्या हो गई? LT-1. Now we come to AT. A is acceleration and T is time. So acceleration का formula क्या होता है? Acceleration is velocity upon time. So this is LT-2. And we write the dimension of AT. It is LT-2 into T. यहाँ पर T की पावर -2 मल्टीप्लाई बाय T. So -2 plus 1. LT-2 plus 1. It is equal to LT-1. Now what do we see? We see here left hand side the dimension is LT-1, U again LT-1, and AT again. On solving we get dimension LT-1. This means this equation is correct. This means that this equation is correct. Each and every quantity independently is equivalent to the quantity on the left hand side. Okay. Now in the next video we will be discussing the uses of dimensional equations. Okay. In the next video we will be discussing the uses of dimensional equations.